continue working with inequalities, only this time we're going to be applying multiplication and division to isolate the variable. Since this skill is not really brand new, we have a repeat of our two vocabulary words. First, we have inequality, which you already know right now, is a statement that is formed by placing an inequality symbol between two expressions. Next, we have an equivalent inequality, which means inequalities that have the same solution. Let's get started with the first of our 4 examples. Solve the inequality and then graph your solution. So remember, our goal with working with inequalities is the same as it is when we work with equations. We want to get the variable by itself, and we're going to use inverse operations to do that. Let's read the inequality. It says 8n is greater than or equal to a negative 72. So what's happening to the n right now? Well, right now this n is being multiplied by a positive 8. And the opposite of being multiplied by a positive 8 is to be divided by a positive 8. And so we're going to do that on both sides of the equation. On both sides of this inequality. We are going to divide by our positive 8. When we do, we have created a coefficient of 1 for our n. And we have n is greater than or equal to a negative 9. Negative 72 divided by a positive 8. So we're done with half of our task. Secondly, now we have to graph our solution. So what we'll do is we will put a number line of sorts. We need to put our negative 9 on our number line. And let's see where our solution set lies, to the left or the right. And n is greater than or equal to a negative 9. Since it's greater than or equal to, we color in our circle above the negative 9 because negative 9 is included in the solution set. And then we draw our arrow going to the right to show that the numbers in the solution are greater than the negative 9. Okay, let's move on to example number 2. Our directions are the same as they were for the first example. We're going to solve the inequality and then we're going to graph it. Let's take a look at what we have. Here we have a negative 8.3 is greater than x divided by a negative 5. Now, if you think back to when we learned how to use multiplication to undo division, that's what we're going to do here. Since the x is being divided by negative 5, we need to multiply both sides by a negative 5 to get the x by itself. So we have a negative 8.3 times negative 5. And then we have x divided by negative 5 times negative 5 over 1. And remember, the reason I put our negative 5 in a fraction is because we're multiplying it by a fraction. I think it's just easier on the eyes to have it balanced. Now, there's something that is different with inequalities when we are multiplying and dividing. If you are multiplying or dividing by a negative number in order to get your variable by itself, then what you need to do is reverse your inequality symbol. So if you see right now, our original inequality is negative 8.3 is greater than x divided by negative 5. Now, in order to get the x by itself, since right now it's being divided by negative 5, we've already stated that to undo that, we have to multiply both sides by negative 5. Now, when we do, on this side, we get a positive 41.5. And on this side, we get our x by itself. But as I started to say before, when you have to either multiply or divide your variable by a negative number in order to get it by itself, you have to reverse your inequality symbol. So while we started out with greater than, we end up with a 41.5 being less than x. Now again, this is only if you are multiplying by a negative number or dividing by a negative number to get the x by itself. And now we have to graph the inequality. Here, I will put our 41.5. So you see the fact that we have a decimal here doesn't change anything that we do. But you notice we have the variable on the other side of the inequality. When you are reading this for graphing to find out where your solution set lies, you have to start reading from wherever your variable is. See, all along we've been reading from left to right. But I did this purposely because you need to get acquainted with having it sort of what looks backwards. So if you read it from the perspective of the variable, what this says is that x is greater than 41.5. So you see, even though we're reading this left to right, that 41.5 is less than x, it's still true. We didn't say anything that was false. But in order to graph it, it makes it easier, I think, if you read it from the perspective of the x. X is greater than 41.5. Since it's greater than, we have an open circle over the 41.5 because it cannot be included in the solution set. And if x is greater than, we draw our arrow moving to the right. Let's take a look at our third example. Okay, let's take a look at this word problem. What we're going to do is read this problem, come up with an inequality, and then solve it. You need to read at least 105 pages of your novel for English class in 1 week. How many pages should you read each day? Now, the reason this is an inequality is that you can read more than 105 pages, but at the very least, you have to read 105. And so we're going to write our inequality, assuming you're going to try to read the same number of pages every day. So since, let's see, we have our 105, and we are going to read 7 pages every day. So I'm going to express that as 7D. Now it's time to fill in our inequality symbol. The least number of pages that you can read is 105, which means that anything you read has to be greater than or equal to it. Because if you read anything less than 105, you will not be fulfilling the assignment. Since you're allowed to read more than 105 pages, we put the inequality symbol greater than or equal to. So now what we have is just a one-step inequality, one step towards solving it. Here, 7 pages a day, 7D. Since D right now is being multiplied by 7, we are going to divide both sides by 7. And when we do, we have the D by itself, one easy step. We find that D is greater than or equal to 15. So again, because this is a word problem, you'll write out your answer in a complete sentence, that you should read at least 15 pages a day in order to read 105 in a week. But you can read more. And finally, our last example. Write the verbal sentence as an inequality, solve, and graph. A number multiplied by -9 is no more than 1.08. So let's take our first piece. A number multiplied by -9, that means -9 x, or any variable that you want, is no more than 1.08. That means 1.08 is the highest that it can be. So every number in our solution set has to be less than or equal to it. So now we have negative 9x is less than or equal to 1.08. Right now, that x is being multiplied by negative 9. The way to undo that is to divide both sides by negative 9. When you do, you get a coefficient of 1, and you have the x by itself. When you do your long division here, 1.08 divided by negative 9 gives you an answer of a negative 0.12. I just want to remind you that since we had to divide our variable by a negative number, we have to take our inequality symbol and reverse it. So instead of having less than or equal to, we now have greater than or equal to. So our solution set is any number that is greater than or equal to a negative 0.12. So we'll put that here, 0.12. If x is greater than or equal to it, we circle it, and we color in our circle to make sure that we include a negative 0.12 in our solution set. X is greater, so we make our new arrow moving to the right. So now I think you have a very good handle on how to solve inequalities. We have learned how to use addition and subtraction, and now multiplication and division. The steps are the same as you follow when you are solving equations, but the one big difference is this. When you are multiplying the variable or dividing the variable by a negative number, remember to reverse the inequality symbol.